Okay, so for this circuit, we have to find the energy obtained in each capacitor. So this is something new here. That we have this capacitor, and first we're gonna go start off by trying to find out what the current may be passing through this capacitor. Well, the current passing through will actually be zero because we're gonna look at this formula. So to find the current passing through a capacitor, it's equal to the capacitor itself times the change of the voltage over the change of time. So we're gonna make the assumption that it's been a really long time, and time is equal to infinity. So it'll be the change of voltage over infinity, which is zero. So that means the current passing through here will be zero. Okay. Now, if the current passing through this capacitor is zero, then we can actually do an open wire here. All right, and then now we can just pretty much ignore this portion of the circuit. And same with here. We'll assume the same thing. So the current passing through this region is also zero. So it's an open wire here. So we're now left with the following circuit. All right. So this is the circuit now. Now what we want to do is let's try and find the current passing through this region. So we know the current, let's do mesh. So this will be 0.006 amps. And this one, let's call this value I. Okay, so let's solve for mesh I. For mesh I, it will be 3000 I minus 0.006 plus 2000 I plus 4000 I. Now we can solve for I. So it will be 3000 I. So 0.006 times 3000, that's minus 18 plus 8000 I. So now we have, hold on, 11,000 I is equal to 18. Oh wait, sorry, I made a mistake. 2000 plus 4000 is 6000, not whatever I wrote. So it will be 9000 I equals 18. So I will be equal to 18 over 9000. So it will be 0.002 amps, or just 2 milliamps. Okay, now let's go back to our original circuit here. So the current passing through this region is going to be 2 milliamps. And now we can use this information to find out what the voltage will be stored at these two capacitors. Okay, and then after that we can find the energy stored in each of them. So to find the voltage stored, it'll be the difference of the voltage at this region and this region. Okay, so let's find the voltage at this region. So the current passing through here, what will it be? Well, it'll be the difference between 6 milliamps and the current that was passing through here. So we can just look at here. So let's find the voltage at this region. So it'll be 3000 times 0.006 minus I was 0.002. So we get, let me see what I get. We get 12 volts here. Okay, so that means the region at this point will be 12 volts. Now, as the current passes through here, our voltage drops. So it'll be 12 minus 2000 ohms times 0.002 amps. So we get 8 volts here. 8 volts here. Okay. So now the difference between 12 and 8. So 12 minus 8. What does that give you? That gives you 4. 4 volts. So the voltage at this capacitor will be 4 volts. Now to find the voltage at this capacitor, it's going to be the voltage, the difference of voltage from here to here. Okay. So obviously we don't care about this 5 kilo ohm resistor, because remember the current passing through here was 0. So we can just put like a long wire here, pretend that's not even there for now. And we know the voltage down here is 0 volts. That means the voltage at this capacitor is 8 volts. Okay. So now we can use all of this information to find what the energy will be. To find energy in a capacitor, it's equal to 1/2 the capacitor times the voltage squared. Okay, so for the 2 millifards. Oh yeah, by the way, for capacitors, it's in fards. It's something called fards. So F means fards. So it's going to be for the 2 millifard capacitor, it's 1/2 the capacitor itself, so 0.002 times the voltage, which is 4 squared. And that gives me, hold on, that gives me 0.016 joules. And for the 4 millifarad capacitor, it'll be 1/2 times 0.004 times 8 squared. So that gives me 0.032 joules. So those are your final answers.